Everyone. Today we're going to look at the lead code problem, set matrix to zeros. So for this problem, you'll be given a matrix of size m into n, and some of the values in the matrix will be set to 0. So your problem, what it should do is that given this matrix, any row and column which has the 0, we should also change the values for those rows and columns to be zeros. So yeah, they've given us a few examples here. The center row is 0, so we just change the center row and the center column to 0. And here's another example. We set the first row, first column, and the last column to 0 because these two values were 0. So for this, they've also given us a follow-up by saying that the solution, we can have a solution which is of the space complexity O of m into n, which means essentially you create another matrix of the same size, and while you're traversing the first matrix, you keep adding values the second matrix, and that way you can keep track of which ones need to be 0. But that's not the ideal solution. So they've said that you can have a slightly improved solution of size O of m plus n. So yeah, first we'll try implementing a solution using this space complexity. So easy way I can think of is using a hash set. So what we could do is we can traverse the first matrix once, record all the rows and columns that need to be 0 in two separate hash sets, and then we traverse it again and then set the values to 0. So yeah, I'll just demonstrate that quickly. So hash set. I'll call it rows. Similarly, I'll create a separate one only for the columns. So now I'm just going to create two for loops to traverse all of the values inside of the matrix. So find So the way we're going to do is if the value inside of the cell is 0, we're just going to add it inside the row and column hash set. So we just say rows.add and columns.add. So yeah, so we are going to do it the first time we're going to traverse it to store all the values. Next time we're also going to do similar traversal. I'm copying it so I don't have to write it again. But here what we'll check is if the rows contains that particular row number. So what we say, if rows.contains So yeah, hopefully that made sense. So essentially what we are checking, if we add everything to a hash set and just while traversing it again, we confirm if the row or column is supposed to be 0. So we'll try running the solution. And both the use cases have passed. Let's try submitting it. So yeah, for this solution, the time complexity of O of n into m, where n is the number of rows, m is the number of columns. The space complexity O of n plus m, because essentially we're just keeping two hash sets, and the only thing they're doing is keeping count of which rows and columns need to be 0. So this solution works, but what they've asked us to do is, can you devise a constant space solution? So we, in this, for that, we need to make sure we don't even use a hash set at all. So there are several ways to solve it. The easiest way I could think of was we use the first row and the first column as a way to mark down. So what we do is we just say whichever row and column needs to be 0, we mark those cells in the first row and first column. We set those values to 0, and then when we are traversing, we use those values as comparison to determine which rows and columns need to be 0. And for the first row and first column, we handle it as a special case. So what we do is the first before starting the program, we just traverse them, determine if the first row and column need to be 0, and then we start processing the rest of the program. So yeah, I'll explain it better after. I think you'll understand better if I solve it. So what we do is we create two Boolean values. The first thing I'm going to do is check so for that what we'll do is we'll create a for loop. So for in I. So we're going to check the first row and we're going to see if any of the values are already 0. So if so, this is already the first row. We just say first row equal to true. And yeah, can essentially break because you don't need to process more. So we can do something similar for checking the first column as well. So what we say first. So same logic. Here the column will always be the first column. The row will keep incrementing, and we'll check essentially if there's a 0 already present there. And yeah, you'll understand better now why I'm storing those two values separately. So next thing we need to do is we need to traverse the remaining matrix. So I don't know why it's that row. Let me just update this. So essentially what we'll check is if the value of the cell is 0. So if matrix I so the value is 0, what we do is we just mark the 0 in this first row and the first column. So what we say is matrix equal to 0, and we also say matrix I comma 0 is equal to 0. So this way we are going to indicate that this particular row and this particular column should also be made 0. So yeah, first time we're just going to collect all the zeros and we're going to traverse the matrix again, but this time what we're going to do is that if I comma 0, we just say matrix ij is equal to 0. So yeah, essentially what we are doing is we are marking which cell should be 0. So this solves it for the remaining part of the matrix, but for the first row and first column we need to go back and process it. So what we say is that if first row, so we already determined that there's a 0 present, and so we just need to set all the values in the first row to 0. So if first row, yeah, we'll create a for loop again. And some similar logic we need to do for the first column as well. So if first column, so essentially what we need to check that all the values of that first column need to be set to 0. So yeah, for this solution everything is being done in place, so that it is constant space complexity, and for time complexity it will be O of n. So yeah, let's try running it. So yeah, put the use case as pass, try submitting it. Like I said, time complexity will be O of n into m, where n is the number of rows, m is the number of columns, and it's because we are essentially traversing it twice. But yeah, it's a linear solution. For memory complexity, everything is being done in place, so constant space-time complexity. And this problem is categorized as a common Facebook coding interview question. Leave comments. Let me know there's an easier solution for it. And yeah, thanks for joining.